Okay, kids, here we go. This is your mirror drawing project explanation help thing. Now you should have downloaded the mirror drawings. There are 5 of them or 6, I don't remember. Maybe 6, there's at least 5. And you have to draw these out. Now draw these out to scale. What that means is you're gonna need paper and you're gonna need a ruler. Having a compass is helpful. Of course, you need a pen or a pencil, really helpful. So you're going to need some paper. When drawing these out, sometimes you can fit 2 drawings on a piece of paper. Notice I'm holding the paper sideways. You're going to want to do that. Trust me, you. Because when you have these drawings, they'll sometimes take up so much space, you'll need another piece of paper. There is a chance, depending on how you set it up, for one of these drawings that it might even require a 3rd piece of paper. Yeah, I know, I get it. You kids you got it rough. So now this is usually what you're gonna need. 2 pieces of paper, tape them together, whatever, glue them together, whatever, spit on them, as long as they hold together, whatever, line them up. Of course, you're gonna, send me photos of these, so I guess you don't actually have to attach them. You can just make sure they're lined up when you take the photos. So put the paper together, again, sideways, and then start the drawings. I think the last one is one that will utilize a convex mirror, so you'll need more. I always draw them when I start them. I would draw them, of course, principal axis, I'll draw across here. I'm gonna do this on the board for you and show you what it would look like. I draw my principal axis, I put my mirror over on here, over on this side. Because I know that with a concave mirror, not all, but most of my drawings are going to end up being over here. So I kind of use 3/4 of the paper on the left to make that drawing, and a little bit of extension in the back if I need it, if we get a virtual image in the back. All right, so flip it sideways, get yourself several pieces of paper. Sometimes you can, draw one up here, one down there, get a couple of them on a piece of paper, save you some paper, save a tree. All right, you got your ruler, maybe your protractor. No, we don't need a protractor. But strike that. Wrong. Not a protractor. A compass. Okay, so what do? We get our questions and we look. Okay, I'm going to make something up here in my head, and it's not far off from what you'll have to do. An object is placed 18 centimeters from a concave mirror that has a focal length of 12 centimeters. Okay, now what would I do? Take your ruler, measure. First thing you want to do is draw a nice horizontal. And I'm going to use different colors today because on my camera, on my phone, it's much clearer and we can see those sweet colors. I'm going to use them. Draw a nice horizontal line. Okay, horizontal line. A little tilted, but that's okay. You'll do better than that. Yes, you will. You got a ruler. And then put a point. I usually put the point, again, 3/4 of the way over, like over in here. Just pick a point, whatever. That's going to be your vertex where you're going to draw that curve of the mirror. And it doesn't matter now how you draw that curve. The curve, how you draw it, matters. So we're going to have to know how to, get that curve correct. Next I would do is I would draw on the focal length. Now I had said a concave mirror with a focal length of 12 centimeters. So I go ahead and I measure out 12 with my ruler. 12. Measure that out, 12. And I put F, and we all know that the center of curvature is twice as far as the focal length. So I measure out another 12, or 24 centimeters away. Measure that out, 24 centimeters, and put C. Okay, now you might be saying, hey, is he doing one of the problems? No, I just made it up. I don't know what the problems say. Just making this up as an example of how you would do it if you were drawing it out. Okay, let's see. So at this point now, I would draw in the mirror curve and do it well. It's going to matter how you draw it. The mirror curve will lead to error if you don't do it right. You have 3 choices of how to do this. 1, get a compass. Compass, put the pointy part, so don't stab yourself in the arm, but stab the paper and then put the pen or pencil, whatever you got connected into it here, and then draw from the center of curvature, not from the focal point. All right, that happens a lot with students when they first start doing this. You draw your center, you draw your mirror from the focal point. Well, you got a really curvy mirror, and it comes out all messy. No, wrong. Center of curvature. Okay, then, if I don't have a compass, you can make one up. Yes, you can. You can make a compass. Take a pencil or a pen. Take a, what do you call that stringy stuff? String! Take a string, wrap it around, and at the end of the string, hold it here at the center of curvature. Put your pencil or pen here, draw. You can do that. The other thing you can do is that you now know you've measured this out to be 24 centimeters. So take your ruler and hold the ruler here, 0, and go 24. And make some points. 0, 24. 0, 24. 0, 24. So you can make several points that are 24 centimeters away from the center of curvature. Put those points down. Now you have enough points you can just freehand it in. So you just go, all right, well, I have enough points now. I can see how to draw the curve correctly. Okay, those are the 3 ways that you can make that curve correct. And it doesn't matter how you draw that. Okay, now you go ahead and you use your 3 lines. So let's say I've got an object that's 12, 18 centimeters from the vertex. Always measure from the vertex. Everything's measured from that point where you put the mirror. Now I draw my 3 lines. Now you might say, well, wait a minute, what about the height of the object? What about that? How high should I make that? It doesn't say on the thing. It doesn't tell me how high the object is. I always make the objects 1 centimeter. 1 centimeter. So cute. Yes, you are. So cute. 1 centimeter. Now, well, doesn't it matter? No, it won't. It won't make any difference. The math won't matter. The drawing won't matter. You'll end up with the same drawing. No matter how big that object is, you'll still get the same magnification. That's a ratio. You'll still get that. You'll get the distance correct. It'll all be good. Trust me. Trust me. Come on. You can trust me. I'm not wearing a tie. All right, so I usually make that 1 centimeter high, and then I go ahead and put my 3 lines in. Parallel focus. Parallel. Of course, when you do this, you're going to use your ruler. Okay, use your ruler so it's nice and straight. And sometimes making a parallel line, I notice when students will do this, like I'll see them working in class. I mean, a lot of you are going to be working on this at home. So here's what you don't draw a parallel line. You think you're drawing a parallel line, but it's not, and it matters. It's a little bit off, makes a big difference. If you're off just by like a smidgen here, when you project that back, that smidgen becomes a mega smidgen. So you have to have accurate parallel lines. How do I do that? How do I do that? Well, if you make this, let's say, for example, 1 centimeter high, go over to the mirror and mark 1 centimeter high on the mirror. Go, okay, that point right there, that's 1 centimeter. Now you can connect those points, parallel line. So go ahead and measure out from your object 1 centimeter, you know that, and you go ahead and make a 1 centimeter mark here on the mirror and then connect those 2 points. You've got parallel, not just 1, but 2 L's. That's a pair of them. Oh, wait. It was a good one. Thank you, Nick. Okay, so now we've gone parallel focus. Again, you're going to use a ruler and get it right. Then we're going to go focus parallel, focus, doink, and parallel. Now to make a parallel line here, again, what I would do is I would measure how far down I hit the mirror. We hit that 6 centimeters down. And then I'd go over here somewhere and I'd measure out 6 centimeters and put a dot, put a dot here. And then I go ahead and connect those points so I know I have a parallel line. If I don't do that, if you're off by a smidgen, smidgen becomes a mega smidgen. Remember that, mega smidgen. So I go ahead and draw in, that's far down, and I measure that out here. Okay, of course, I'm eyeballing this now, but you won't eyeball it. You'll measure it because you people are good. You're good. And we go ahead and go like that. All right? Now we draw our 3rd line, which in this case would be through the center of curvature, up to the mirror, back down. Remember that center curvature line always just goes back on itself and comes in like this. And this is actually going to be a good example to talk about something. If I look at those, okay, they don't meet. I messed it up. I gave you one problem to do that's similar to this. I did. I remember giving you one where there's the object between the focal point and center of curvature, and you end up getting this they don't all connect problem. Okay? So this will happen, probably happen to you. And what happens when that happens is you now have these intersection points that don't all meet, so you get this triangle looking thing here. So where should I put the image then? Where do I put it? I put it in the middle. Pick the middle of the triangle. Put it there, a dot, and then go ahead and draw your image back. It's taking an average of those points. Now you might say, well, why don't they all meet? It's because you messed it up. If you look at it, that's actually pretty good for freehand. Thank you. And you're going to get the similar situation. And what I mean, it's not because you've done anything wrong. This is actually showing a phenomenon that happens with large curved mirrors or with mirrors where the connection to the mirror is a long way away from the vertex. That's a good distance away. The farther away we get from the vertex, the less accurate our image is. And that's not anything you've done wrong. It's the nature of the business. The nature, and there's actually a name for that called spherical. I should probably make that capital. Spherical aberration. Spherical aberration is what happens to curved mirrors if they're either very large or you hit lines that are a long distance from the vertex. The closer you are to the vertex, the more accurate and more clear your images are in a curved mirror. This is a phenomenon that shows up even in the drawings that we have an image that's going to form out here and it'll be a little bit blurry. Most of you who didn't see me use the BFM, the big frickin' mirror. You didn't see me use that. When I was using that, I was getting an image. Then I was playing around with them, I'm going, I need to get this focus. It's very difficult to get a focused image on a very large curved mirror. Like if you have a little makeup mirror, like in the morning when I put my makeup on, I have my little makeup mirror. I got to pencil in my eyebrows because I don't have any. And so when I use my makeup mirror, okay, it's small. Very accurate, very clear image, which is unfortunate for me. I got to look at that face. I know you got to look at it too. I'm sorry. Large mirror, not accurate, a little blurry. We get this phenomenon happening. So when we draw this out, they don't all meet. You're actually showing what happens with large curved mirrors, or when lines are a long way away from the vertex and they connect to the mirror, you get fuzziness. So you will have a drawing that looks like this. Okay, I can't remember what number it is out of the things. Now, it may be the first one. I think it might be the very first one that you'll draw. Okay, so at this point, what would I do? Would I be done? Would I move on? No. Describe. Use your descriptor words. Okay, describe. This is the image, and write on your paper what it is. Remember, you have to give it 3 words. All right, that is enlarged. There's the object. There's the image. The image is bigger than the object, enlarged. It's upside down. It's on the other side of the principal axis than the object, so inverted. And then you would say real because it's on the same side. When the image and object for a mirror are on the same side, that's a real image. We have ourselves a real image there. Okay, so now do the math. You have to draw them and do the math. How do I do the math? Use the mirror equation. You got 2 of them. I want the math for the distance, and I want the math for the height and magnification. Okay, so let's go ahead. We'll do an example. To get the distance of the image, we say 1 over f minus 1 over do. That's our equation, our mirror equation to solve for the distance of the image. Now, I have to remember what I used for the numbers here. Let's see if I can do it. Okay, the focal length we said was 12, or I said it was 12. So I go 1 over 12. Okay. 1 over 12 minus, I put this at 18. I put it halfway between. Minus 1 over 18. Okay, so do the math on that. Common denominator, I'm going 3/6, baby, 3/6. So 1 over di is 36. Now you can use whatever one. You want to use 360, you go ahead and do it. American. Don't let anybody tell you what to do. You're American, yeah. So that goes into there 3 times. that goes into there 2 times. Do the math. You get 1 over 36. But then remember to flip it. Make like coin, flip it because you want DI. You want DI, not 1 over DI. So that is a 36. And this was measured out in centimeters. So the image should appear 36 centimeters away. And if you look at my drawing, if this was 18, then 36 on my drawing would be about right here. So even freehanding this out, you know, that's a relatively, it looks like it lines up pretty well with what the math says, the math in the drawing, basically agreeing with each other here. But wait, we're not done. Now, calculate the height of the image. What should the height of the image be? Okay, high. Remember, if you want to get high, you need di. Go. This is a proportion. Hi ho equals di do. So hi ho, we need ho, we need do. Okay, all right. Don't die. Don't do that. That'd be bad. And then go ahead and plug in the numbers. Now you have all the numbers. You have 36 for the distance of the image. So let's see. Are you still in view here? Are you still looking? Okay. So 36. The height of the object. I made it 1. It won't matter. It's a proportion. Make it 1, make it 2, make it 3. It's up to you. I make these heights 1 centimeter. So 1. Makes the math just a little bit easier. Divided by the distance of the object, which we had set out here at 18. So 36 divided by 18, we get the height of the image will be 2. And that also makes my magnification factor real easy to calculate. That's why I like using the height of the object. When I go ahead and draw that arrow in, I like using 1. Now we can compare very easily and get a very quick magnification factor. So this is going to be, height of the image is 2 centimeters. Of course, I had originally drawn the height of the object is 1 centimeter. So now I know my magnification factor. M is going to be, okay, M is negative hi ho or di do. You can pick those. Either one works for magnification. Hi over ho, di over do. So go ahead and pick. I'm going to go with hi over ho. So hi, ho, height of the image, hi, height of the object, ho, and there's a negative there. What's the negative for? The negative is there to help you mathematically determine if the object will be upright or inverted. Yeah, check it out. This is going to end up being a negative 2x. I like putting an x there for a magnification factor, so it's twice as high, 2 times as high. And the negative means that it's inverted. If you have a negative for a magnification factor, that's why the negative is put into the equation here for magnification. It helps us determine whether or not the image should be right side up or inverted. If it comes out to be a negative, it's inverted. Okay, all right. Well, isn't there always going to have a negative there, right? This is always going to be positive, always be a negative, so every image is inverted. No. Some of these will come out to be negative. Trust me, you're going to do the math, and sometimes that height comes out to be a negative. So that means a negative is a positive, you'll get an upright image. Trust me, do the math. You kids, do the math. Don't believe me, I usually wear a tie. All right, so now back to this. So now I would have a complete drawing. Drawn at scale, determined using my descriptor words. I didn't write those down, those descriptor words. You would write this down. You would say enlarged, real, and inverted. Now you've got the math, you've got the drawing, everything is there. Move on to the next one. Okay, all right. I think that's a good description of how to do these problems and what you need to do for each and every one of them. I will come back. I'm going to take a short break here, and I'll be back and give you another short video on some special cases.